Yeah, so let's do a couple of exercises using the graphing calculator to find the approximate location of some zeros. So here's your problem. If a quintic fifth degree polynomial function, type that into your graphing calculator and try to find your x-intercepts. Approximate those. Pause that video and then come back and check your work. Alright, so let's call up our calculator here. So when I call up my calculator, there it is graphed, and I can see, sorry, that was a little bit of spit. I can see that it crosses the x-axis 3 times. 3 times? What? I have a degree of 5, which means that 2 of these things must be imaginary. Pull this graph back up again. So the first one is at negative 2.18, and then I've got one real close to the x-axis, negative 0.32, and then finally last one, 1.11. Okay, not too bad, not too bad. Right, so the next one is an application problem. So a tachometer measures the speed in RPM, revolutions per minute, and that is the speed at which the engine shaft rotates. It's not the same thing as the speed that you're going, okay, because your engine will sometimes turn faster than your wheels are turning, okay, and so that's what that tachometer is measuring. If you drive a stick shift transmission on your car, you usually have one of these things, and you use it as an indicator when you're supposed to switch gears. You get good at it, you don't even have to look at that thing, you're just listening to the engine switching gears at the appropriate time. Okay, anyway, for a certain boat, the speed x of the engine shaft in hundreds of RPM and the speed s of the boat in miles per hour are modeled by that cubic function. So there's a weird number 26 just floating there. That's strange. Anyway, so in real-world applications, the coefficients of all your variables are very rarely integers. So that's why we've got those somewhat scary-looking numbers there. But don't worry, we're approximating these things in the calculator. So the question is, what is the tachometer reading when the boat travels 15 miles per hour? Okay, so 2 hints here. First of all, what you need to think about is, where does that 15 go? Does it go in for x, or does it go in for s of x? So think about that. The second hint is apparently this red number 26 down here. So pause it, give it a try, and see what you think the RPM is supposed to be. Okay, so let me go ahead and call up the math on that. Let's see what that 26 is about. So what you needed to do is take that 15 and plug it in for s, not in for x, because it's the speed of the boat. And we're trying to find out what the RPM is for the engine, which is the x value. So I plugged the 15 in for s, subtract it over, there's where that 26 is coming from, that negative 26. Put that into the calculator and then find where it crosses the x-axis. So let me go ahead and call up the calculator again, and let's take a look. That's the old graph. Let's go back to y equals. Notice that I've got a little black rectangle around the equal sign. That means it is highlighted, it's selected, it's ready to go. Let me scroll over, press enter on it, and it turns it off. I'm going to go down to the second one, hit enter, and it turns that one on. Okay, so if I hit graph, which is on the standard window, do I have I sure don't. And I don't see enough of the picture. So let's go and fiddle with the window settings. All we really need to fiddle with is the x values. So I know it's not going to be anything below 0, so I'll hit 0 on that. And let's try, I don't know, let's try 20. Okay, so the next one, it says x scale. Usually what I do is I take that maximum value, if it's from 0 to some number, and I divide it by 10, so maybe going up by 2s. Let's give that a try. Let's see what the graph looks like. See if we have enough. Here it goes, here it goes, here it goes. Ooh, it looks like it's almost at 20. So let's actually zoom in out just a little bit more, and let's go to, say, 30 on this and change that scale to 3. Okay, now I should have the x-intercept in there. Ta-da! Yeah, so I can see that it's a little bit below or before the 20. So second trace gets me the calculate menu. I'm choosing number 2. And then I can play this little game. I can hit enter on this one, maybe go 25 for the right bound. I don't want to guess. You tell me what it is. And there it is, 19.86, rounded off. If you look at my answer here, I say 1986 RPM. Why? Well, because it says that this is in hundreds of RPM, so I just moved the decimal place over 2 places. Alright, so that concludes the exercises on this objective. Let's try the next one.